Sometimes it feels like math has this secret language, right? Well, today we're going to crack the code on one of its coolest concepts, square numbers. You might think, oh yeah, that's just a number times itself, but they are so much more than that. They follow this set of beautiful, kind of hidden rules, and together we're about to uncover them. So, to kick things off, how about a little puzzle? Take a look at these four numbers. Only one of them could possibly be a perfect square. Now, I know what you're thinking. Gotta grab the calculator. But hold on. By the time we're done here, you'll have the secret code to solve this in like 2 seconds flat. Seriously. All right, first things first. We've got to start with the basics, build a solid foundation. We're going to define what a square number even is, because before we can start spotting the fakes in our puzzle, we need to know what the real deal looks like. So what exactly is a square number? It's really simple. It's just what you get when you multiply a whole number by itself. I like to picture it literally. Imagine a square, and each side is 5 units long. What's the area inside? Yep, it's 5 times 5, which is 25. That area, that 25, is a perfect square. Okay, here's a quick but super important detail, one that trips a lot of people up. Square numbers are always positive. Always. You might be thinking, well, what about negative numbers? Great question. Remember, a negative times a negative is a positive. So -7 times -7 isn't -49, it's positive 49. Okay, foundation is solid. Now for the really fun stuff, the detective work. We're moving on to what I call the level 1 clues. These are the quick, easy telltale signs that let you instantly tell if a number is even a candidate for being a square. And our first secret? Well, it's all about the ending. Seriously, just looking at the very last digit of a number is this huge flashing clue. It can be a total dead giveaway. And here it is. This rule is an absolute game changer. A perfect square will never, and I mean never, end in a 2, a 3, a 7, or an 8. That's it. If you see one of those digits at the end, boom, it's out. Disqualified. And this isn't just some random magic trick. It's baked into the very math of how the numbers from 0 to 9 work when you square them. All right, on to secret number 2. This one is all about zeros. Now, if a number ends in a 0, that's interesting, but it's not the whole story. What really matters is how many zeros are at the end. And here's the rule, plain and simple. A perfect square has to end in an even number of zeros. That's a must. So think about 400. It has 2 zeros, right? That's an even number, and yep, 400 is the square of 20. But what about 4,000? It has 3 zeros. That's an odd number. So nope, can't be a perfect square. It's another one of those super fast checks you can do in your head. So we've got the easy, surface level clues down. Now it's time to go deeper. We're going to look at the hidden patterns, the ones that are kind of woven into the very DNA of every single square number. Okay, this next one is so simple, it's almost beautiful. It's all about even and odd numbers. Turns out there's a really clear, unbreakable pattern here. Just take a look here. An even number, like 6, when you square it, you get 36, which is also even. And an odd number, like 7, you square it and you get 49, which is odd. It's a perfect match every single time. An even number can't make an odd square, and an odd number can't make an even one. Impossible. All right, you ready to level up? This next test is a bit more advanced. It involves a tiny bit of division, but man, it is one of the best ways to sniff out an imposter. So check this out. It shows just how consistent these numbers are. If you take any perfect square and divide it by 3, the remainder, the leftover part, can only be 0 or 1. Same thing if you divide by 4. The remainder will always be 0 or 1. If you ever get a remainder of 2, you know for sure it's not a perfect square. Let's try it out. Take 49. We know that's a perfect square, right? It's 7 times 7. Okay, so if we divide 49 by 3, we get 16 with a remainder of 1. See? It works. The rule holds. This is such a great final check when you're not quite sure about a number. Okay, so we know how to spot them, but how are they actually made? Where do they come from? Well, this is what I call the grand reveal. We're about to see how these numbers are built, right from the ground up, and it's really cool. I have to admit, this is probably my favorite thing about square numbers. It's just so elegant. It's almost poetic. Get this.
Every perfect square is just the sum of consecutive odd numbers starting right from the number 1.
Just watch this. So 1 squared is just 1. Simple enough. Now 2 squared is 4, right? Well, that's just the first 2 odd numbers added together. 1 plus 3. And 3 squared is 9. Well, that's the first 3 odd numbers. 1 plus 3 plus 5. It works every time. This amazing pattern just keeps going forever. But wait, there's more. The magic of square numbers doesn't just stop there. They're also a huge deal in geometry. In fact, they're the building blocks for one of the most famous ideas in all of math.
And that brings us to Pythagorean triplets. You've probably heard of a squared plus b squared equals c squared, right? Well, these triplets are just sets of 3 whole numbers, like 3, 4, and 5, that fit that equation perfectly. They're the numbers that make up the sides of a perfect right-angled triangle.
And what's so incredible is that you can actually generate these triplets using a simple recipe that's all about squares. Just pick a whole number, let's call it m, as long as it's bigger than 1. So let's try m equals 3. The formula gives us our 3 sides. So with 3, we get 6, 8, and 10, and guess what? It works perfectly. 6 squared is 36, 8 squared is 64, add them up, you get 100, and 10 squared is 100. It just shows that squares aren't isolated things. They're out there creating other cool patterns in math.
All right, we've learned the secret code, we know the telltale signs, we've seen the hidden patterns. We get it now. So let's circle all the way back to that puzzle from the beginning and solve this thing.
Okay, let's use our new superpowers. First number, 2342. Ends in a 2. Nope, impossible. Next, 9,000. It's got 3 zeros in an odd number. Can't be a square. Next, 5678. Ends in an 8. Also impossible. So what does that leave? Just one number left standing, 729. It's the only one that doesn't break our rules, and yep,